In last class, we studied the states of matter, which are solid, liquid, and gaseous. Our today's topic is, can matter change its state? Before exploring this topic, students, I will ask, what are the three forms in which you get water? You can easily tell. The solid form is ice, the liquid form is water, and the gaseous form is water vapor. So it is clear that matter can change its state. So what are the conditions on which matter change its state? We will explore it. The physical state of any matter can be changed by any of the method discussed here. First, by changing temperature. Second, by changing pressure. And third, by changing both temperature and pressure. Today we will study how the state can be changed by changing temperature. Students, in this flowchart you can easily see that when solid state is heated, it turns to liquid state. When liquid state is heated, it turns to gaseous state. You can think example of water. When you heat the ice, it melts to liquid. It means water. And when you heat the water, it forms water vapor. This process can be reversed on cooling. Now students, in solid, the intermolecular forces are very strong and the consistent particles are closely packed. On heating, the kinetic energy of particle increases and at a stage it becomes sufficient to overcome the binding forces in the solids. At this stage, solids start melting and the solid get converted into liquid. Similarly, on further heating, liquid converts to vapor. Now we will explore more by the help of this activity. In this activity, we will study the conversion of ice into water and then the conversion of water to water vapor. To perform this activity, students, you need beaker, thermometer, burner and an iron stand. So here in this activity, we have taken some ice in a beaker and we are heating it. When you will heat the ice, you will observe that the temperature in the thermometer increases rapidly and the rise in temperature will occur till it reaches to the level of 0 degrees Celsius. This is a laboratory thermometer and you know that laboratory thermometer has range of minus 10 degrees Celsius to 110 degrees Celsius. So student, we will observe that while melting the ice in this beaker, firstly the temperature will increase and when we will reach at the level of 0 degrees Celsius, then the rise of temperature will stop and we will see the ice will start melting and it will form water. Okay students, now moving to the next activity, to the next part of this activity. When we will heat the water, after melting ice, the water will form and when we will start heating the water, again there will be rise in the temperature and up to the mark of 100 degrees Celsius, the temperature will keep on rising. When the temperature will reach at the level of 100 degrees Celsius, then again it will stop rising and the water present in the beaker, it will turn to water vapor. Now students, we have discussed the observations. During conversion of state of matter, the temperature doesn't change. Now we must know why this happens. On increasing the temperature of solids, the kinetic energy of particle increases. Due to increase in kinetic energy, the particles start vibrating with greater speed. The energy supplied by heat overcomes the force of attraction between the particle. We can conclude that the amount of heat given by us is utilized to overcome the force of attraction between the particle. This is the reason that the temperature in the thermometer doesn't rises. The minimum temperature at which a solid melts to become a liquid at atmospheric pressure is called its melting point. The melting point of a solid is an indication of strength of force of attraction between its particle. Students, we simply can say higher is the melting point, higher will be the force of attraction between the particles. Now student, the melting point of ice is 0 degree Celsius or 273.15 Kelvin. Melting is also known as fusion. We observe that during melting of ice, the temperature of system doesn't change after melting point is reached. For ice, it is 0 degree Celsius till all the ice melts. Here, the heat supplied to the system get used up in changing the state by overcoming the force of attraction between the particles. As this heat energy is absorbed by ice without showing any rise in the temperature, it is considered that it is a hidden heat and we called it latent heat. Now students, there is one term which we have to know, latent heat of fusion. The amount of heat energy that is required to change 1 kg or you simply can say 1 unit mass of a solid into liquid at atmospheric pressure at its melting point is known as latent heat of fusion. The SI unit of latent heat of fusion is joule per kg. This is. Now student, we observed that when we were heating the water it start boiling. We must know what is boiling point and related terms. Boiling point is the temperature at which a liquid start boiling at atmospheric pressure. Now, boiling is a bulk phenomenon, which means it depends on the amount of substance taken. If you will take 1 liter water, it will boil earlier than boiling 10 liter water, which means the amount of water decides the timing of boiling. Now, the boiling point of water is 100 degrees Celsius or you can say 373 Kelvin. Students, there are 3 scales for measuring temperature. First, Celsius, second, Fahrenheit and third, Kelvin. Celsius is the common unit which we use here, but Kelvin is the SI unit of temperature. Now, next topic is latent heat of vaporization. The amount of heat required to convert 1 unit mass or say 1 kg of liquid into vapor at its boiling point is called its latent heat of vaporization, and it also having SI unit joule per kg. Okay students, I have mentioned it earlier that SI unit of temperature is Kelvin, but commonly used scale is degree Celsius. Student, today we explore many things about the change of state with the help of heat. So that's all students, keep learning.